Hi once again. We were in chapter 1 and we were discussing the binary numbers arithmetic operations. We said if you represent the negative numbers, let me make it more clearer here. If you represent the negative numbers as two's complement form, the problems that we face with sign magnitude representation will be solved. So in here we will be explaining this here subtraction two's complement represented negative numbers. So that's going to be the frame that we're going to examine in this video. So total there are 4 frames, so we're going to follow these frames. Let's follow them. Change the board now. Okay, here you are. So we said all the operations becomes a summation operation if we represent negative numbers in two's complement form. Okay. Now, what are the alternatives? So when you are talking about subtraction operation, we are going to transfer this summation operation. Then there are 4 alternatives. 2 positive numbers subtracted. So after the subtraction operation, it becomes this. So if you represent a two's complement, it becomes this, isn't it? So in this case, it's the one negative number, the other negative number, and subtraction of it. Positive, positive subtraction, negative, negative subtraction. So minus 2, that's minus minus becomes plus. So this is going to be a 2 complement representation of A. So that means that's summation, isn't it? So the first one is positive number, the other one is negative number. This negative number subtracted, so it becomes this. So it becomes the summation operation. In this one, if you represent this as a two's complement, and this one as two's complement as well, so summation of those 2 complement number gives you the operation is summation operation, so no subtraction operation. So look at here, all these operations are subtraction operation, summation operation for all cases of the subtraction operations. What we need is we represent negative numbers as two's complement. If we do this two's complement representation, no problem. Okay, now let's consider this next case. So let me see now the conclusion from here. One of the positive, one the other one is negative. So I can consider this 2 numbers, one of them positive, the other one is negative. So if you replace the position, this is one case. This is another case, isn't it? Summation of 2 positive numbers and summation of 2 negative numbers. So altogether there are 3 alternatives. For each alternative we are going to examine them separately. This is one of the positive, the other one is negative. So the first thing that we should deal with is this. Which number system we are going to be in? Let's say this A and B is in number system N. So we should know what the resulting number, whether it is in this system or we've got to move up one system up. What it means in the n number system, we know that the numbers that we can represent is this, isn't it? This range. So let's say you did that operation and you end up with a number which is not in this range. So that means you're going to increase your number system one up. So change from this number system to this one is called overflow. So this number system is not in our overflow. There is an overflow from that number system to this one. We call it overflow case. So keep that in mind. So let's examine what happens in this case. Under this condition, there are two alternatives. When A is bigger than B, or B bigger than A. When A is bigger than B, what happens? So we know in the normal arithmetic, if the absolute value of A is bigger than B, you're going to subtract B from A, and the sign of A is going to be given to the sign of A should be given to the resulting number. So as soon as we see that minus b, we are going to represent it as Two's complement form. So if we write it, it is written here, but I repeat it here. A is going to be normal A. You don't need to write Two's complement of it because sign magnitude and Two's complement representations are the same. So plus minus b, Two's complement representation is 2 to the power n minus b. So if I write it once more, this is also equal to 2 to the power n a b is the same, isn't it? 2 to the power n is, if you remember that number system 4, we were going to have 4 bits, and that's going to be sign bit. When it is 2 to the power 4, that is 16. 16 is this, isn't it? So that means that one is not inside of our number system, because this is 4 number system we are talking about. So if you consider this n, this 2 to the power n is going to be something like that. That means you're going to have a 1 out of your allowed number system. So if you ignore that, because this result is not in your number system. So if you ignore it, what you found is correct, because as I said already, when A is bigger than B, the resulting number is A minus B. The resulting number sign is going to be the A sign, which is going to be plus. So we can explain here on an example here. Now 7 and 3, this is A. The absolute value is bigger than this one. The result is going to be 4, and the sign is going to be plus in decimal. So if you do it in binary now, that is plus 7, and that is minus 3. How we found that minus 3? 2's complement. So let me do it in here area. That is plus 3, 4-bit, and 2's complement of this one from the right hand side, this is 1, the first one. The rest of them is the complement of those. So that is minus 3, isn't it? Here you are, that's minus 3. So when add those up, 1, 1, 0, you get 1 carry here. 1, 1, 0, 1 more carry here. 1, 1, 1, this is 3. You put 1 here and another 1 here. 1, 0, that's carry. 1, 0, 1 gives you 0 and carry here. So that is the resulting number. Now I am saying if A is bigger than B, ignore that this one, that is this one, that ignore. So what we found is true, including the sign bit, we are saying, because of that result. When you ignore it, you get this. I know A bigger than B, so that's going to be the positive number. So it is positive number because sign bit is positive, and the value is 1, 0, 0. So this is plus 4, isn't it? So this is it. So I explain one thing more here. If you are adding two numbers, one of them positive, the other one is negative, the resulting number is going to be in the same number system. Why is that? One of them positive, the other one is negative means the resulting number is going to be here. Why is that? Because the A is going to become smaller than A, isn't it? If A is in this range, smaller A is definitely is in there. So that means there won't be any overflow if two numbers has got different signs. So that means no overflow. So you can see the overflow case by the carry bit coming to the sign bit and the carry bit coming out of the sign bit. So if you look at this, let me change the color. So the rule is look at the carry bits, which is coming to the sign bit. That was the sign bit. That's coming to the sign bit and coming out of the sign bit. Those two, if they are the same, no overflow. No overflow means you are in the same range. Mathematically, it could be proved, but I'm not going to prove it. I'm explaining it through an example. Okay. So the other case is when B bigger than A or A is smaller than B. So then this the resulting number is going to be a negative number, isn't it? If it is negative number, we are going to represent it as two's complement form. And we definitely know that that number is going to be in the same range or number system range. So let's say it is plus 3 minus 7 in this case. So this is bigger than this. An absolute value is bigger than this. So 3 that's the plus 3 with that was plus 3. Minus 7, so that is plus 7. To find the minus 7, we're going to get the complement of it. Complement of it, that is first 1, 0, 0, 1. So that is plus 7. So you look at here. So that is plus 7. Sorry, that is minus 7, of course. That is two's complement representation of minus 7. So that's the minus 7. If you do the operation 1, 1, so carry is going to be 0 here. 1, 1, 1, there's going to be a carry 1 here, isn't it? 1 plus 1 gives you 2, isn't it? 2 is 1, 0, so put the 0 in, carry here. So 1, 1, 0, 0 here, and 1 more carry here. One zero zero one, but no, it doesn't become 2, so that's 1. So there is no carry here. It's going to be this. If you do this operation, no carry here. So if you look at the carry bits coming to the sign bit and coming out of the sign bit, they are the same, aren't they? If they are the same, no overflow. This is what is expected. We already know that one of them positive, the other one is negative. There's no overflow. You're going to stay in the same number system. So what happens this case? Let me change the color to a different color to differentiate this one and this one. In this one we said A is going to be positive, B is going to be negative, so I'm going to represent B as 2's complement form. So A plus 2 to the n minus B. So that is minus B, and I know B absolute value is bigger than this one, isn't it? This is what we said here. we said the resulting number is going to be the highest absolute value number sign. So that's the result is going to be negative. So if I write this now, 2 to the power n minus ba. So what is this? So if b is bigger than a, the resulting number value is going to be b minus a, isn't it? We know that. The sign is going to be the one of which absolute value is bigger. So it's going to be negative. So this is the representation of a negative number. Of this negative number, absolute value is b minus a. So that's the correct result, isn't it? So in this case, the resulting number is going to be correct, including the sign bit, because it's going to be a negative number, and the resulting number is the 2's complement representation. So this concludes what we found here is going to be correct, and we know we are in the same number system. So 5, I am not going to consider this 5th bit because I am in the 4-bit sign, 4-bit number system. So this is 4-bit number system is enough. I am saying in 4-bit system, why we are still in 4-bit number system? Because one of them positive, the other one is negative. Range does not change. So I am in the same range. And if you look at this number now, this number is a negative number because of this 1. What is the value of this negative number? Find the 2's complement of this. So let's do it now. I am going to start from the right hand side and go towards the left hand side and write down all the bits that I observe until the first one I get. So that means I'm going to write what I see here, including the first one that I met. The rest of them is going to be 0. So what is this? That is 4, isn't it? So the result is minus 4. How I said that minus 4? Because I said this is a negative number. The value of this negative number, I said it is 4 here. So this is a 2's complement representation is minus 4. So that means, in this case, my conclusion is, including the sign bit is correct. If put them together, those two cases, says that there won't be there won't be overflow. We stay in the same number system range, and the result number is always true within that system, including the sign bit, because we have represented negative numbers as 2's complement form. So what is the next one? Next one is b plus b case. So that means both of the numbers are positive numbers. What happens? There are two cases that for this example I can say it easily. It said plus 3 plus 4 gives you 7. So our range system, number range system was minus 8 plus 7. So 3 is in the range, 4 is in this range, and 7 also is in this range, isn't it? So that means there's no overflow. So you could see it is no overflow here. So that means a carry bit coming to the sign bit, carry bit coming out of the sign bit, if they are same, no flow. So this is only one XOR gate, see. If you say that this is XOR gate, one of them is carry in, carry out to sign bit. Sign bit coming to the sign bit, carry. Coming out of the sign bit is this carry. If they are the same, the result is 0. If they are different, the result is 1. No overflow, and that's overflow case. So I can detect overflow by using one XOR gate. Now let's come to this area. So these are mathematically could be proved. I am not using this mathematic here, and I am giving you how it is done through an example. So okay, then we said this is no overflow case. There is an overflow case. Let's say this 7 and 6, once again, -8 plus 7 is our range. So 7 and 6 is in this range, isn't it? So this equal also included here. But 13, the resulting number, is not in this range. So there is going to be an overflow. So that's going to be this output of this XOR gate is going to be 1 here. And it's going to be 0 in this case. So we've got to examine those two separately now. If it is the case, that means there's no overflow case. And the number is +3, that's +4. Add them up, 1, 1, 1, 0. So since there's no overflow, so I'm going to consider these 4 bits. So the sign bit is the most significant bit. It tells that this is a positive number. The value is this, so +7. The conclusion is correct. If you come to this one, add those up. There is an overflow. If it is overflow, that means you're going to use 5 bits. So this is the 5 bits. Since the most significant bit is 0, so it is a positive number, the value is next to it. That's 13. So that's the correct result. Conclusion is this. Whether there is an overflow or there is no overflow, summation of two positive numbers, resulting number, is always true. When there is no overflow, you're going to consider n-bit number system. When there is an overflow, you're going to consider n+1 number system. We know the rule, sign bit is the most significant bit. So you're going to keep this in mind while you are making the decision. So the next one is both of them negative case. So it is written here. In here, there is no overflow. You stay in the same range. So you could see it here, -8 +7 if n is equal 4 and equal. -3 is in this range, -4 is in this range, -7 is also in this range. So if it is -7, -6, -6 here, -7 in this range, but -13 is not in this range. So you're going to use one upper one is going to be -16 +15. So it is in this range. So you could see it here. So consider this one. -3, we already found that. -5, you can repeat it here. That is +3. And -3 is 1. Rest of them, the inverse of it, 0, 1, 1. So that is -3. 4, this is 4. So 2's complement. Until the first one, you're going to write what you see down here, and the inverse for the rest of it, so it's going to be 1. So that's this one, that's -4. So when you add them up, so 1, 0, 0, 0, 0, 1, 1, 0, you've got to carry 1, all of them add them up, 3, 3 is 1, 1, put that 1 here, the another carry here. So if you look at here, carry bit coming to the sign bit and coming out of the sign bit, they are the same. So there's no overflow. If there is no overflow, you're going to use the same number system. Ignore this. Don't look at this because there's no overflow. You're going to use 4-bit number system. And that number, including the sign bit, is true. Let's check it. When you see that 1, 0, 0, 1, that is, you can say that this is a negative number. What is the value of this negative number? Get the 2's complement of this. Two's complement, start from the right hand side, the first one here, and inverse rest of them. This one, isn't it? So this is 7. So this is minus 7. Here you are minus 7. Minus 3 plus minus 4 gives you minus 7. So including the sign bit, it is true. Overflow, that means you stay in the same number range. So when you come to this one, you see there's going to be an overflow here. The carry coming to the sign bit, carry coming out of the sign bit, they are different. So there is overflow. When there is an overflow, you're going to consider 5 bits, not 4 bits, 5 bits. When it is 5 bits here, you've got that 1. Because of that 1, let's examine this one now. 0, 1, 0, 0, 1, 1. Because of that one, it's a negative number. The value of this negative number, you've got to two's complement. You've got to find the two's complement of this number. So that one written here, and the rest of them is going to be inverse. 0, 1, 1, 0. So that is 12, that's 13. So this is minus 13. Here you are, minus 13. 1, 0, 0, 1, 1. That's the same, isn't it? So that was that number, and I am saying that this number represents minus 13, so that's minus 13. So let me say the conclusion out of these slides. Conclusion is this. We know that for operations, arithmetic operations, become summation operations if you represent the negative numbers in two's complement form. In two's complement form, the sign bit problem would disappear. The problem that we face is sign magnitude representation case. That's different. 2-0 representation, we already examined, no problem. Now in this examination, we are saying the sign bit problem disappears. All we've got to do is this. We are going to determine the overflow. Overflow determination is very easy. The carry bit coming to the sign bit, carry bit coming out of the sign bit, you're going to exclusive OR of those two values. The resulting value, if it is 0, that means no overflow. If it is 1, that means overflow. If there is no overflow case, you're going to stay in the number system you're in. That means including the sign bit, for this case, always your conclusion is true. If there is an overflow, you're going to consider your resulting number is in higher number system, n+1 number system. So you're going to consider this n+1 number system. In this case, most significant bit shows you the sign bit, and that sign value is always correct if you represent negative numbers is in the two's complement form. That is the conclusion. So end of this as well.